Hey everybody, welcome to a new tutorial. Today we're gonna have a look at how to create a fully procedural roller coaster. And I'm using the newest version of Blender, which is 3.0, released this week. This tutorial is gonna consist of two parts, and in part 1 we're gonna have a look at the nodes, and in part 2 we're gonna do the shading and lighting. We will release part 2 in the coming weeks, so stay tuned for that. And the first thing we're gonna do is to create a spline. So let's shape our track first. Gonna start with a big ramp before. And then something like this. Let's flatten this. And I'm gonna move this out a bit, like a real roller coaster. And we're gonna close the loop like this. Let's see, there's a way to close the shape. Toggle cyclic is that one. So now we have a closed shape. Alright, and the first thing we need to do is create our track itself. So what we're going to do is create a circle. And we're going to make a couple of copies. And we're going to space them out, something like this. And after that we're going to merge it. So select the bottom one, the last, and then go to join. So the pivot point is over here. And after that we're gonna create our geometry nodes. Let's call this track shape, for example. And just create any object for this. And call it geometry nodes. I'm gonna go into the geometry node editor and press new. And we can throw away this one. It's gonna delete our plane which we just created. And I'm gonna pin this specific object so we don't lose our node network, because we're just gonna work on a single network. Okay, first thing we need to do is import our objects. So we're gonna import these two. Let's see, we can use curve to mesh. Oh. first one is going to be our track shape. And the other one is going to be our profile curve. Let's call this profile curve. And drag it to the output so we can see what we're doing. Interesting. Right. So make sure that's a curve. Okay. Now let's scale down our shape, because it's clearly way too big. And for that we need to go into the point mode so that our track actually scales. Because the position is not related at the moment. It's only gonna look at the pivot point. Okay, let's just double check which is the top. Okay, these two. The other way. Okay, now we're facing upward. Alright, so there we have our first piece. Next up we need to create the sort of support, which is not that hard. We can create a curve to points, input our track shape, and we're gonna output points. And on these points we're gonna instance. Instance on points. We're gonna input the points we created over here and create a join geometry. We're gonna create a box outside of the geometry system, geometry nodes, and we're gonna call this support. And again, we're gonna drag this in. This is gonna be our instance. And input the rotation like this. And then in point mode again, we can start scaling. Oh, and I like to use X-ray for easier selection. Okay, make it quite small like this. Actually gonna move it over here so that we see what we're doing. we need to rotate it again, like before. Let's find the right axis. The advantage of geometry nodes is you can change anything on the fly, so you don't have to give a lot of thought how you position things and stuff like that, because you can just see visually what you're doing and adjust it accordingly. So for example, this needs to be oriented like this. Make sure to align it to the original pivot point. That's the most important part. And then just position it so it fits on the track. Something like this. Gonna scale this a little bit down. Alright. This needs to go a bit higher. Okay, that's looking good. After that we can adjust the count, and we're gonna adjust it by length. Oh. Be careful with this number. The advantage of setting the length instead of the count is for this reason. If we ever want to adjust our shape, our length will stay the same while our track is getting longer, so this is a nice way of distributing this specific item. Okay, let's put it on the side. Next up we're gonna need supports. And this is gonna be a little bit more difficult, so I'm gonna make some space for it. Let's start by making a cylinder. And we're gonna do something similar again. Create a join geometry. Get our cylinder in. We're gonna get points again. Input our track shape once again. And we're also going to instance again. And instance our cylinder. Let's rename it to poles. And adjust it again. Increase this, because we're not gonna need so many. And something we're gonna do with this one is we're gonna specify the length of it. First, make sure the pivot point is in the top of the cylinder like this. And we're quickly gonna create a grid, because we need a little landscape for our track. Let's pull our track shape a bit upwards. And let's subdivide this a couple of times. And let's sculpt a couple of mountains. Something like this. Alright, and now it's going to be a bit more difficult. Let's move these over so they are outside of our scene. And we're gonna create a raycast, which is gonna set the scale. So what a raycast does is it's gonna check if a ray sent from a point is hit. For example, is it hitting this landscape? And if it does, for example, yeah, it will give a length. That's the point. So this is our target geometry. And as you can see, this is not working because we need to separate our X, Y, and Z. Let me double check this in my example file. Okay, that's it. We need to do the combine XYZ. And these need to be set to 1. And again, we're gonna adjust it to our liking. After this, we're gonna add one more layer of complexity to this, so don't adjust it too much just yet. Okay, let's see why this is separated like this. Oh, this is clearly wrong. Okay. Right, because we need to have our landscape as relative because of these adjustments we made. And as you can see, this doesn't exactly match up, and that is because we're multiplying the scale value by something which was not, for example, 1 meter exactly. So if you just adjust it by the eye like this, it's gonna work. Okay, next up, we're gonna add some rotation. We're gonna get the rotation from our points. we're gonna separate it. And combine it again. And we're only gonna grab the Z. After that we can add a math node. Oh, actually we need a vector math. Let's make some space here. And add it to the rotation. And then we can offset our pole. Let's pick the right axis. Yeah, we need this one. And set this, for example, to 0.2. And then we're going to create another one. And set it to -0.2. And we're also going to copy this one. And get everything, instance, our points, and rotation, and our scale. And add it to our join. Okay. Now we have two of our poles. Let's try to organize this a little bit. Okay, we're gonna create one more instance on point. We're gonna add a cube. Let's call it connector. This is just a little extra detail. Throw this in, connect this up. Get our points again. Oh. And let's see, are we gonna separate the rotation? Yeah. Okay. You can make it something like this. Alright. As you can see, now we have a problem over here, which is these overarching poles are blocking our track. So what we can do is go to our raycast and connect isHit with our instance to points. So these are our poles. Yeah, actually we need to connect all of them. And what we can do is reduce the length, and at some point they will stop to exist over there. And for example, we could create another type of node for that. Another type of support, I mean. Let's call it high pole. And let's move it a little bit so we don't get confused. Let's join them. You can model anything you want here, but let's delete part of it. Yeah, I guess we're gonna need to keep it two separate elements in this case. Because these poles we're gonna scale again. Let's call this high pole connector and these just high pole. And let's create another raycast. Get this target geometry. And let's drag these two in already. It's gonna instance. Okay. Now what we can do is create a look at the length of the raycast and use this one, math node, with a greater than value. So if the hit distance is greater than this value, we will use our higher poles. So this is our top length for now. So again, we can use the hit distance. To drive our scale. Oh. These need to be set to 1 again. Okay, so this could already be something. But since we're working on it, let's just create the other one as well. Another copy. And connect it up. Interesting. Need to connect the selection as well. Okay, so it will only exist over here in the highest point. And we can still adjust our track. Yeah, over here it will create a different type of support. If we want to go really specific, we could also create another node. We could create another. We could use our normal to drive this specific pole, because our normal over here faces the other direction, because it's upside down, our track at this point. And with that we could make a difference between a looping like this or just a really high area like this, like the beginning of our track. So I'm not gonna do that today because yeah, these are just the basics, but that's just a little tip if you would like to be more adjusted a little bit more. So okay, so now we have our track and we still need our cart, so let's work on that. This is gonna be our cart. And actually we're not gonna create this in the geometry nodes, but we're just gonna use the old system. So let's use a object constraint, follow path, and use our track shape. We'll move this to 0. And use follow curve. And can use an expression here. What is it? Frame. Actually, we can also just hit animate path. Okay, so it's way too big. Let's use a local space. Interesting. Our track still looks to be curved a little bit. Let's try to fix that. Yeah, actually we could just do this. Okay, so that's one, and copy and paste it, and then just offset the second one. And there we go. There we have our basic track. We still need to adjust this. Can tilt like this. That looks a little tight. We can all right. And that's our landscape for now. So yeah, hope you like it. Of course this system can be expanded upon, but we covered a lot of the geometry nodes. So this tutorial will be followed up by another tutorial in which we cover the lighting, shading, and we might expand on our system, and we'll answer any viewer questions, so stay tuned for that. Alright, thanks for watching, and I'm looking forward to your creations.